When I'm doing triangle trig, I need to familiarize myself with a number of trig functions. I will do that in Desmos. The first thing I need to do when I go to Desmos and I'm working with triangle trig is to change my settings from radians to degrees. Now the three basic functions we're going to be working with are sine, cosine, and tangent. If I want to evaluate the sine at a certain degree, I can just type in sine of, for example, 40, and it will give me that value. Same with cosine, same with tangent. So those are pretty straightforward. The other thing that I need to know how to do is how to find the inverse sine of something. So for now, I'll show you guys how we're going to apply that later, but for now, I'm going to bring up the keypad. I'm going to go to functions, and for example, here are my inverse trig functions. So the inverse sine of, for example, 4/7 is this, 34.85. The inverse tangent, or inverse cosine of 4/7 is 55.15. And I can also do the inverse tangent of, for example, 4/5, and it tells me that it's 38.66. So that's what you're going to need to know how to do for today's lesson. Use the sine, cosine, and tangent function, and the inverse sine, inverse cosine, and inverse tangent function. For this video, we're going to be working strictly with this one triangle. This triangle is not drawn to scale, and it's going to look exactly the same regardless of what different sides I have on it and the different angles. So let's start out with the three definitions. Sine of an angle is the ratio of its opposite side to its hypotenuse. The cosine of an angle is the ratio of its adjacent side to the hypotenuse. And the tangent of an angle is the ratio of its opposite side to its adjacent side. You can also think of it as sine over cosine. So let's look at alpha. Alpha is this angle right over here, and the sine of alpha is the measure of the opposite side over the hypotenuse, so 3/5. Cosine of alpha is the adjacent side over the hypotenuse, which is 4/5. And the tangent of alpha is the ratio of the opposite side over the adjacent side, which in this case is 3/4. Now I want to look at beta. Beta is this angle right up here. Sine of beta is the opposite side over the hypotenuse, 4/5. Cosine of beta, see if you can take a second and figure out what that is, 3/5. And finally take a second and see if you can come up with what tangent of beta is. So tangent is opposite over adjacent, so 4/3. Now, my triangle now went from a 3/4/5 to a 5/12/13. Same idea. See if you can come up with what the what is the sine of alpha in this case. So sine is still opposite over hypotenuse, 5/13. Cosine of alpha, same idea. Figure out the two sides that you're going to be taking the ratio of, 12/13. And finally, tangent of alpha. Again, figure out what are the two sides that make tangent, opposite over adjacent, and I end up with 5/12. I want to be able to use the sine function to calculate a certain angle. So now I want to find the measure of angle alpha. And I want to use sine to find it. So the first thing I'm going to do is I'm going to set up my ratio. Sine of alpha is 5/13. It's opposite over hypotenuse. Now, I want to get rid of my sine function, and the way I'm going to do that is with an inverse sine function. So I'm going to take the inverse sine of both sides. Inverse sine of sine is just going to be alpha. And the inverse sine of 5/13, I'm going to go to Desmos and I'm going to calculate that. I'm actually not going to go to Desmos. We went over how to do that at the beginning of this video, but I would want you guys to go to Desmos and figure it out yourselves. When you do that, you get alpha is 22.62. If you didn't get that, maybe you're in radian mode. For my fifth example, I want to use cosine to find the measure of angle beta. So cosine is adjacent over hypotenuse. Cosine of beta is 5 over 13. The way I get rid of cosine is take the inverse cosine of both sides. I'm going to take the inverse cosine of both sides. That gives me beta by itself. And the inverse cosine of 5/13 is 67.38 degrees. Notice what I got last time, measure of angle alpha, and what I got this time, measure of angle beta, together add up to be 90 degrees, which makes sense because my third angle already is 90, and the sum of the degrees of a triangle adds up to 180. For example 6, I want to use tangent to find the measure of angle alpha. I've got this 4, 3, 4, 5 triangle, and tangent of alpha is the opposite side over the adjacent side, opposite over adjacent. Tangent of alpha is 3/4. I want to get rid of the tangent and have alpha by itself, so I'm going to take the inverse tangent of both sides. Inverse tangent of the tangent of alpha just gives me alpha, and the inverse tangent of 3/4, when you plug that into Desmos, or any kind of calculator for that matter, you get the measure of angle alpha is 36.87. Now, if you wanted to find beta from here, you could just subtract that 36.87 from 90, and you would end up getting beta. For example 7, I want to calculate the measure of side A. I'm going to look at what am I given. So I'm given this angle, which is 25 degrees, and I'm given a side that's adjacent to it, and I'm also given a side that's opposite. So opposite and adjacent, that means I'm going to be using tangent. Those are the two sides that give me that ratio. Tangent of 25 is a divided by 4. Now I'm going to rewrite that as tangent of 25 divided by 1 is a over 4. And the reason I want to set it up this way is so that I can cross multiply. So a times 1 just gives me a. 4 times tangent of 25 is 4 times tangent of 25. I can plug that directly into my calculator, multiply 4 times the tangent of 25, and I should get 1.865. I'm using 4 sig figs here. I don't want to simplify before I have to. That way there's going to be fewer rounding errors. Example A, I'm going to calculate the length of B. B is the hypotenuse, 25 is my angle, and 4 is my adjacent side. So I've got an adjacent side, I've got the hypotenuse, which means I'm going to be using, see if you guys can figure out what we're going to be using here. If you said cosine, kudos to you. I'm going to set up my cross multiplication proportion. Cosine of 25 over 1 is 4 over b. When I multiply both sides, I get 4 is b times the cosine of 25, and now to get b by itself, I just divide both sides by the cosine of 25. b is 4 divided by cosine of 25, and now that's when I want to put that into my calculator. I don't want to do that beforehand because I want to round as little as possible. So 4 divided by the cosine of 25 gives me 4.414. Now, that is a reasonable answer. I know that whatever I get, if what I got was less than 4, that would be bad because 4 is, B's my hypotenuse, and that's going to be my longest side. So if I got it to be something like 2.59, that could not be a right answer. This doesn't mean that 4.414 is the right answer, but it's a reasonable answer. As long as it's anything greater than 4, that's a reasonable answer. For example 9, I want to calculate the length of A. Again, pause the video, see if you can set it up, solve it yourself, and I'll go over the answer in a second. Hopefully you had a chance to set it up. I've got an adjacent side, I've got a hypotenuse, and my angle is 35 degrees, which again means I'm going to be using cosine. Cosine of 35 is a over 7. Setting my proportion, I get cosine of 35 over 1 is a over 7. When I cross multiply, a is 7 times the cosine of 35, which works out to be 5.734. Again, that's a reasonable answer because it's less than 7. For the final example, I want to calculate the length of b. Once again, I'm going to pause the video, or I want you to pause the video, work it out yourself, and then see if you get the same answer as I did. I have a side that's opposite. I've got a hypotenuse. Opposite and hypotenuse means I'm going to be working with sine. Sine of 35 is b over 7. I'm going to set up my proportion, cross multiply, and b is 7 times the sine of 35, which works out to be 4.015. Again, that's a reasonable answer. It's less than 7, so I've got to feel pretty good about this. So that's how we can use sine, cosine, and tangent, along with inverse sine, inverse cosine, and inverse tangent to solve right triangles. Now, if you don't have a right triangle, it's a little bit trickier, but we'll worry about that next time.